Hello, and welcome to the next session in the J Champions Conference. Excel and Andres, are you ready?
Yes, more than ready.
Perfect, let's go.
Thank you. Well, thank you very much. Hello from Switzerland. And you should be able to see my slides. I hope you can see them. And this is all about dependencies and Maven Puzzlers. So usually I give this session with Andres Almirai. And he's here actually, but he's sick. So this time I have the honor of it. And Maven Puzzler, this is a dependency edition that I like to present. And I think we're only seeing my camera. So let me see if it's something on my side.
Just need confirmation from Gerton that the slides are being also sent.
Yeah.
Are they visible? Maybe.
Let me try. I can stop and share again because this session is totally interactive. So while we figure this out, perfect. While we figure this out, it's all about doing a quiz. So you will see the questions and hopefully we can answer them at the same time. So this is a little bit about me, but as you have guessed, I'm from Mexico. I'm living in Switzerland. I'm a Java champion. That's why I'm here. I work for JFrog, and I actually participate in a lot of open source foundations and community. And I have collaborated in some books. And even though this is a remote session, we have our local audience here. So this is going to be a nice, totally interactive session. So one of the things, I'm a software developer, and one of the most important things for me is to develop in a calm, relaxed way and use the best tools for it, or prefer those tools that are predictable, automatical, reliable, and are based on conventions or can adopt conventions. So when I talked about tools, I picked my favorite ones or the ones that are most common, and they actually are my favorite ones. So why Maven Puzzlers? Because in the Java domain, chances are, even if you don't have Maven as your selected build tool, you will be using it because you probably are consuming POMs or BOMs. So, for example, in this particular survey by JRebel on the Java Developer Productivity Report of 2022, the last year, Maven has 68% of the market in the build tool area. And this one from JetBrains in the development ecosystem for 2021, you can see as Maven, again, it is close to 70% of the market share. So these are the reasons why we are going to talk about Maven. And in the slides, you will always find a QR code. That means that you can scan it and it will take you to either the sites like Apache Maven, or will tell you to the GitHub repository, or even help us with the Mentimeter or the quiz, the online quiz. So let's talk about jars, but not that kind of jars. The jars that are representing our dependencies. And it's important to notice that dependencies are not always the same. And in our world in software development, we have made everything more modular so we can leverage and mix and match and build on the work of other people. But what happens when we don't move at the same rate? We can find the same dependency, but with different version coming from our other dependencies. So at the end of the day, when we start talking about dependencies and dependency management and dependency resolution, that sometimes is our experience. A little bit of desperation and a lot of questioning. So I have a question for you is what do you actually do when you start a project? When you do a git clone from your version control system and you start any project. Like this is your first day in a new project, you have just cloned the source code. What do you usually do? Most of us is going to build the project. And if this project happen to be a Maven project, what is the command that you run? Maven clean install. So there is a person out there that has a very opinionated view on Maven clean install. I'm referring to him. And well, I can tell you, I'm not going to go into all the reasons why you should use Maven clean install, but I can suggest you to use Maven verify. Most of the times will do what you expect. And the reason why it's going to do what you expect is because the first line that you can see here is the phases of the default Maven workflow. So as you can see, whenever you are actually executing Maven clean install, and if you execute Maven verify, you are very, very close. So what you can see here is the different stages. Some of them are in gray, some of them are in white. The whites are the ones that we know most of the time, and the gray ones are usually hooks, where plugins do something before processing resources, or before doing a clean, or before doing a site command. So as you can see, Maven verify and Maven install are very, very close. The only differentiation between them is that, for example, if you are working with the Snap versions, what is going to happen is Maven clean install will actually install them in your local Maven repository, while verify will only prepare everything as install without executing that specific part. So if your project is simple enough, you are more than welcome to use Maven verify. The other thing that Maven does for us quite nicely, and nicely, it's again, well, no, actually quite nicely. I also present to JavaScript and other languages communities, and believe me, we are advanced. We are the, oh my goodness, best language out there. But anyway, I'm not going to go in the dependency resolution management, but I'm not going to go into any runs here. What I'm trying to do with this beautiful graphic, and I'm saying beautiful graphic because I did it by myself. So is to represent that, for example, what happens if we have the same dependency from different dependencies our software depend on. If it's the same version, there is no problem. We have consensus and we include that one. But the problem starts when we don't have consensus. So what happens if one specific dependency is bringing an X version and another dependency is bringing Y version? Then somehow we have to include one version. So which version is that going to be? And this is the whole reason of this session. We're going to put you in some examples that I hope make you realize how does this process happen. And whenever you read a POM XML, you will be able to know what is going to happen instead of waiting for exceptions or random behavior. I hope that's not the case. So, as I said, we are going to use Mentimeter, and this is totally a highly interactive session. So if you scan this particular QR code, thank you, Andres. It's so nice to have an assistant. I should do this more. Okay, sorry. If you scan your QR code, then you will enter into the Mentimeter quiz. And please do so, or you can also use the URL and enter that code. I think the QR code is easier. So I'm going to leave it for a little while there, not a lot of time. And what else you're going, it's actually going to appear on top of on top of every single page that you see. Okay. We already have people there, and actually, because this can be reviewed later on, I left the page to go as wherever you want to go. So the first thing that I wanted to know is how do you install Maven, homebrew, manually, and many other options there. So if you haven't used SDK or Homebrew for installing your Maven version, I actually urge you to do it. Because when we use package managers, they take, yes, thank you. So SDK Man, yes. So one of the things I love about SDK Man is that you can even run a different version of Java Maven per terminal. Forget about environment variables. Forget about uninstalling, linking manually. Not. You can actually ask SDK man what are the versions available, and as I told you, you can execute a specific version in one terminal and a different version in another terminal. So that is power, and of course, all the benefits of using package manager.
So one of the reasons to choose a package manager is automation. So if you're still doing things manually, yeah, that kind of works. But do yourself a favor and automate as much as you can of your daily work. It doesn't matter which package manager you choose. Our preference is SDK-Man. But there are many other choices. Just pick the one that suits better for your workflow and keep going.
Yeah. The next question, and these questions are just like preparing and seeing if you are comfortable with Mentimeter. So which version of you're using? And this is important because there is a specific version of Maven that you should be avoiding. And that the specific version that you should be avoiding is because he had some problem with SSL. So I'm happy to notice that most of you are already in 3.86. So that's great. Maven 4 is right about the corner, but it is important that we select a new version or start using new versions. Why is that? Have you ever heard about the Maven SuperPOM? So the Maven SuperPOM is going to give us a lot of coordinates about the plugins that we are using, even the ones that we don't specify. And this SuperPOM has changed, not with every single version, but it has changed. So it is important that you know what version you are using, what version was used when this particular project was created, and of course, use the latest version if you can.
Which, by the way, for Maven, I think 3.87 was released in late December last year. So the latest version is 3.87. And 3.90 is pretty much in the current state of being released. So I don't think the boat is already out, but the team is working on it. So expect that to come out soon. And Michelle also mentioned Maven 4. There are 2 alphas already out that you can test out. We're hoping that Maven 4 final may be released sometime this year.
And that's important. Please test the alphas because with this feedback to the Maven team, you can make the tool much, much better. Okay, so to use the Maven wrapper, remember when I asked about, do you know what specific version of Maven was what used to create this particular project? Well, if you are using the Maven wrapper, and more if you're using CI/CD already, this stops being a question that you have to have on top of your mind. Because what is going to happen, it is going to create a bundle with a specific version of Maven that the person that is creating, maintaining, or of the build master says that is the right one to use. So if you're not using it, maybe have a look at it. At the beginning, it was an outside project.
It was a project that was born outside, and now it passed through the incubation process, and now it's part of Maven proper. I think the wrapper will be the default or the preferred choice once Maven 4 comes out. But you can use it right now today with the latest versions of Maven 3.8.6, 8.7, and obviously 3.9 coming up. So do yourself a favor as well and give it a try. That also simplifies a few things when you're using the wrapper instead of just using the regular Maven command.
The next question is, do you use the Maven daemon? And I hope you're also using the Maven daemon, because what is happening when you're building a specific project? When you're using a specific project, we have to start a JVM. And starting a JVM and executing Maven, and then obviously building your project or whatever target or plugin or whatever you are doing with Maven, it's going to take some time. So with the Maven daemon, sorry, what we are doing is not killing that JVM after it has been bootstrapped. And yes, thank you very much. So it's going to be there in the background for the next invocation. So this actually makes you faster, or Maven faster, because you don't pay the cost of initializing a JVM every single time.
It's distributed as a set of native executables using GraalVA native image. So the Grail daemon only runs for a handful of platforms. You can use regular Maven or Maven wrapper on pretty much anywhere Java runs, but the Maven daemon is going to be restricted to those executables. But it's thanks to those native executables that the time it takes to bootstrap and run is pretty fast. So if you have encountered long builds, long times with Maven, there are a few techniques that can be applied to the POM file, but as well use the Maven daemon.
Okay, so let's start with actually the content. So when I say that this is working and we calculate the final version of the dependency, is because we're using Maven Dependency 3. So this command will actually show you what is the actual dependency being resolved after building the project. So have that in mind. So, okay, so first of all, build errors, 70%, 27. Okay, let's, it's amazing that you're already answered, but I want to explain this question. So this is a POM, normal, very nice. And we have in the section of dependencies, we have two dependencies. So the first dependency is com Google Waba version 27. The second dependency that we are specifying is com Google Waba version 28. So the first thing is what is going to happen. When we were building this example, and I was like, this is mean. I mean, this is inconsistent. How on earth anybody can answer and like twice? Like how? Well, turns out that this is not a build error. This actually presents you with a specific correct answer.
By the way, this applies for any kind of dependency that has duplicate versions like this. We just chose Guava because it's fun to dunk on Guava and it's very common to find Guava.
It's common Guava.
Yeah, but this is not a Guava specific issue.
No.
This is because you have two dependencies, same group ID, same artifact ID, but different versions. Now, Excel said, this is not a build error.
This is not a build. This is inconsistent. This is weird. This is strange. And this is confusing. It's not a build error. It's actually version 28.
Now, if you're thinking, is version 28 because 28 is greater than 27?
We have some interesting news for you. Semantic versioning. If you're not using it, please use it. Does Maven understand semantic versioning? No.
Nope.
But there is a way. When there is a will, there is a way. There is something like the Maven Enforcer plugin. And this is actually going to solve the first reaction that I had. Like, we are saying like we are saying two different versions, two different version number for the same version. This is confusing. This is evil. This is mean to the poor developer that is going to open your POM file and see and say they couldn't even agree on this. Okay.
Well, to be fair, semantic versioning was created after Maven dependency resolution. So and Maven could have adopted semantic versioning later. The reason why they haven't done so yet in core is because they are very conservative in how they decide to break consumers. There was a question on the chat if Gradle supports semantic versioning. Yes, they do, because Gradle is much more recent and they break compatibility anytime they feel like to.
So I'm not actually saying anything about Maven and not supporting semantic version. What I'm saying is, for me, writing something that is inconsistent and confusing should be a problem. Forget about semantic version and forget about reading the minds of your developers and choosing the latest or the first of the middle one or the most popular, depending on all your transient dependencies. I mean, there are several criteria. So if you use the Maven Enforcer plugin and using a specific rule, ban duplicate POM dependency versions, then sanity returns to your project, which means instead of having a warning, you will have an error saying com Google Guava jar is defined 2 times.
By the way, when you run that particular POM that you showed you before with any versions of Maven 3, there is a warning that appears in the execution. An enforcer turns that warning, well, besides the warning, turns in as an error. If you run the same POM file with Maven 4, that warning is automatically upgraded to an error. You don't need the enforcer. So there are some rules. Of course, the Maven team is aware of these things, and they're able to upgrade the behavior of Maven with the next major release.
Okay, so that's awesome. We have errors when I expect an error, when insanity shouldn't happen. So next example, we have, again, in our dependency part, 2 dependencies. But the first one is Google Guava 28, and the second one, Google Truth, introduces one version of Google Guava, but this is 30 Android, or yes, 30 in Android.
Some transitive release.
Some transitive release. So remember that in the previous example, Maven actually chose not the newest one, but the latest, the second, the last one to be shown in the file.
Yes, it was a coincidence that 28 was the last one defined in the XML and was also the highest number. But the reason why it was chosen was because it was the last one defined in the XML.
It was a position in the file. So now I have as the first position 28, and as the second position, I have a transitive that introduces Guava, but it's actually higher. So what is the reason? The reason is simple. A direct dependency definition will always win against any transient dependency. So in this case, I'm saying 28. And the other ones, it's a transient, it doesn't count. 28 wins because of that reason. Okay, let's go back to our presentation because we want to say something. So what happens with semantic versioning? We don't have semantic versioning in Maven, okay? No. And this was a question asked on March 2020. And Maven never looks to the version, but always at the location in the tree. That's why I said the first time is a direct dependency. So even if it's the first thing it encounters and the second thing that it encounters is the definition of another dependency, which a transient dependency on Guava, this is the second one, which is the latest in the file, but is not the most important in terms of the tree. How many hops to a direct dependency is 1? How many hops to a transient dependency? Well, depends, but usually it's more than 1 because it's a transient dependency. So even Robert actually says maybe there's some rules in the Maven Enforcer plugin that you can use to reach dependency convergence. So if you use that particular rule, you will have these warnings.
So it tells us that, well, obviously Guava, we have 2 different versions of Guava, but the transitive dependencies from Guava themselves can also be different. In this case, we're seeing the checker qual and the error-prone annotations are also different. What this rule is telling us, which we can set the build either to warning, which is the default, or to error, to fail as early as possible, up to you. This is telling us that we have different versions of similar dependencies somewhere in our graph, and depending on the class path order, we may get different results when we test, when we run. This is definitely a potential problem. That's the reason why we have these rules, to surface these potential problems and find a way to fix them.
Can we have something like semantic versioning or define some ranges or require upper bounds? Yes, there is another enforcement plugin rule that you can use. And I went too fast, require upper bounds depth. And as you can see, it will actually tell you that we have a problem.
Then there are more rules that you can choose, and one particular that I like is from something called the Maven Extra Enforcer Rules, which brings one called Enforce Bytecode Version. So this doesn't fix any problems that you may find with dependency versions, but if you happen to consume dependencies with different bytecode level, say you're currently building for compatibility reasons a library that is compatible with JDK 11, if you pull in a dependency from JDK 17 and you publish that library, then your consumers will also be forced to use 17. But you said your library must be compatible at most with 11. So having that version will tell you immediately what you're building. If for some reason, some minor mistake, whatever it is, you are pulling versions that are higher, bytecode versions that are higher than the one that you're supposed to support.
Yes, so all these things can actually make your life easier because we are removing a lot of questions or a lot of problems that could happen in testing or in runtime. So let's go back to the questions, and this is a new example. So now we have the dependency management block, and in the dependencies block, I have only my transient dependency that brings Android, 3001 Android. And in my dependency management block, I have Guava 27. So now I have at the last position of the file or a transient dependency, I don't have a direct dependency defined. I only have a dependency management entry. So what happens here? Well, 27 is the one that is going to win. Why? Because the dependency management, it works as a catalog. So if there is a dependency, a transient dependency coming in, what is going to happen is Maven is going to look at the dependency management entries and say, oh, you have defined that you have a preference for Guava. Whenever I need to include a Guava version of a version of this particular library, you're saying me, you please use version 27. So Google Truth is telling me, hey, you need 30, but you said, no, if somebody asks, please tell them it's 27. So please tell me it's 27 is the actual usage of the dependency management block.
So in this case, basically what the dependency management block is doing is replacing or choosing the version of Guava anywhere in the graph. It doesn't matter how many hops. And as long as there is no explicit version of Guava. Truth doesn't say an explicit version of Guava because we only see truth. We don't see something like, oh, I put Guava right there in the dependencies block. And that's the reason why 27 is chosen. So remember that.
Okay. So next question. In this case, we have again the dependency management block, and we have in our dependency block 2 entries. So what has happened is not a lot. We added just a specific direct dependency, this time version 28. So now we have the dependency management 27, a direct dependency 28, and a transient dependency on 30. So what is going to happen? Well, because we have a direct dependency, that one is going to be used. So it is more important what we have defined our dependency block than our dependency management block.
Right. We have a direct dependency, no matter which version it is, that is closer to the project, and that is going to be the chosen one. Now, does that mean that the version of Guava pulled by truth will be also 28? Well, yes, because 28 has already been resolved by Maven.
Now we're going to do something a little bit more interesting. We're going to add or use two dependencies that they include in their transient dependencies Guava from the different versions. In this case, it's going to be Guava 30 JRE, and the other one is Java 30, but Android version.
What is important is that these two different versions of Guava are at the same distance.
So what is going to happen here? What do we have here? In the dependency block, we add the two of them. Okay, so Oscar, we will talk about that in the next examples.
And by the way, it's just BOM, it's not
BOM.
SBOM. SBOM is a different thing.
The SBOM is the software bill of materials, and it's actually going to show you the exhaustive inventory of all the SHA or whatever, and uniquely identify the different dependencies.
Yeah, we're going to cover.
But we will actually cover some of these questions. But
and Vivek, your question is exactly this case right
yes,
now.
Exactly. So this is exactly the question. So we have two transit dependencies with different dependencies of Guava, and so what is going to happen? Who is winning? In the first example, remember that it won the last entry on the file. Remember?
All right. So in this case, Juice brings Guava 31 JRE, and Truth brings Guava 31 Android. That is the last one defined in the XML, at least from the point of view of your transitive dependencies. So we know now there is no semantic versioning. We are not applying enforcer. So if 31 Android wins, it's not because it's the latest one. It's not because it's the biggest one. The same will go for 31 JRE. So who wins here?
And it's not the last one. It's the first one. Sorry. I mean, it works for direct dependencies, but like it works. The last entry on the file for direct dependencies is the winner. The first entry on a file with transient dependencies is the one that wins.
The first one found that is closest. Remember, we said that Guava was one hop away from both Juice and Truth. So that's why 31 Android and 30 JRE are potential candidates. But because 31 JRE is the first one found, that is the one that is chosen. If you were to invert Juice and Truth, then 31 Android
would have been.
Right? So notice that. What if you decide to sort the POM file? Say, you know what? I would prefer Truth to be defined first rather than Juice. And if you don't have any enforcer, nothing like that, then you now will pull in a completely different version of Guava just by sorting the XML.
So first of all, it's good to know this, that it's a little bit different if it's direct dependency, if it's transient dependency, just keep that in mind. But if you don't want to keep that in mind, use enforcer. It will make your life easier. But keep that in mind. Let's continue. Another one. So we have dependency management and the same case, 2 transient dependencies. Now we're saying dependency management, and we actually inverted the order. So what should now be the end version? I'm happy for all the ones that are already answered because that's true. 28. Why? Because the dependency management works as a catalog, so it doesn't matter what the order says. He said, oh, okay, you told me that if I encounter this, I should add 28, and that is what we do.
So the question is, so if there is a dependency management specifying the version and transitive dependency, well, this is exactly this case. We have a dependency management block that says, if you encounter guava anywhere in the graph, then choose version 28. And we know, given how truth and juice have their dependency graph, guava is somewhere there. So dependency management block will say, oh, yeah, let's use 28. Now, by the way, this is the first block out of 3 blocks of questions. We just covered one single POM file.
The normal one. And there was a question about parent POM, inheritance, and multi-project POM. We are going to start with those questions. So we're going to talk about a parent POM and a child, or the current POM. In the parent POM that you have, let me show image. In the parent POM that it should be on one side. I don't know which side.
That side.
That side.
Left.
Yeah. On the parent POM, we have our dependency block define guava 28. And in our project POM,
or consumer,
we actually said, I have a parent. This is my parent. These are my coordinates for my parent. And I also have a dependency block. So in my dependency block, I said I only have a transient dependency to guava, and I'm using truth 113. So which one is the one that is going to be used? So who is right? The parent, the child, the consumer? Well, yes. Actually, this introduces now the concept of POM resolution, and this is also where the super POM comes into play. Go ahead.
Sorry. Coordinated coughing.
Yeah, sorry.
So as Michelle mentioned earlier, Maven resolves the capabilities of your project based on a hierarchy of POMs. And at the top, there sits the Maven super POM. This is the one that says, oh, here's the Maven compiler plugin and the jar and a few others. And it might provide dependencies. In this case, it doesn't. But once Maven resolves your whole project, it goes in this way. First, it reads the child. If there is a parent POM, then goes into the parent POM. And if the parent POM has another parent, then goes into that one until it reaches the super POM, and then brings down the stack. When it reaches the super POM, it says, I give you all these plugins. You don't have any dependencies. I'm done. Then it goes into the next one. It says, oh, you are the parent. The parent says, I have a dependency, an explicit dependency, a direct dependency. So I grab that and put it in something that's called the effective POM. Okay, so right now, so far, in the effective POM, what will you have? Default plugins for super POM, default settings for the super POM, and explicit direct dependency.
Explicit 28.
Right. And then comes into the child and continues reading and says, oh, you have a transitive dependency on truth. Puts that into effective POM. So when you look at the effective POM, what do we have? A direct dependency 28 and a transitive dependency on truth. We know this case already.
We have seen already this.
When we have a direct dependency, that will always win over whatever is brought by the transitive, which means version 28 is the one that wins.
Perfect. We got that one right. So let's see another example. In the parent POM, we have now a dependency management block on version 26 and a direct dependency on version 28. And in the consumer, we have a dependency, a transient dependency. So who is going to win?
Remember that what I just mentioned, the order of evaluation of the parents and the hierarchies, this will eventually result into an effective POM that has a dependency management block, a direct dependency, and a transitive dependency. We have seen this use case before. It was one of the first questions that we asked earlier. So who is going to win?
It's going to be 28 because that is the closest definition of a direct dependency. In this case, it's coming from the parent. The dependency management block, it is just an advisory. And in the consumer POM, we actually don't have any direct dependency. So who wins? The only one that is actually defining the direct dependency. Let's continue. And in this question, we have a different thing. Now we have in the dependency management block version 26, and in the consumer, we have a dependency on version 113. It's a transient dependency. So this is actually, we have seen it, and it is one of the most simple cases. And I'm happy to see that most of you got it right. So we have a transient dependency, but we don't have, when we define a transient dependency, we're actually not fixing that particular version. We ask to the dependency management block to tell us, do you have a preference? And the preference is version 26.
So when these two POMs are resolved into a single one, the effective POM, it is as if you have written one POM file with a dependency management block and a set of transitive dependencies, just one. We have seen this case before, and we know that dependency management is going to win. That's why the chosen version is 26 again.
Okay. Now, let's see this one. This one, in the parent POM, we have the dependency management with version 26. What has changed is now we also have a dependency management on the consumer. So now what's going to happen is we seem to have two entries on the dependency management when we have the effective POM. So now the question is, what happens? My parent has an opinion on my suggestions. I have an opinion on my suggestions. And there is somebody that is asking, do you have any suggestion? So what is the solution here? Well, turns out that the consumer POM has the last word.
Right. So when the effective POM gets created, the first block, dependency management, is found in the parent that gets added. Then the child is read, and it finds another dependency management block. And because it has the same coordinates, group ID and artifact ID, then the child gets evaluated as latest, overrides whatever is coming from the parent, which means that kind of like the effective POM forgot it had Guava 26 as the chosen version. It will be version 28. And this use case is back to what we had before, a dependency management block and a transitive, and we know what's going to happen. The dependency management block is going to win.
Now we're going to go into the specific topic that somebody asked us. Not the SBOM, the software bill of materials, but something a little bit different. BOM files with a B. So in this case,
and we need to. So a BOM is actually the proper name is BOM POM because it happens to be still a project object model. A BOM POM defines a set of dependencies that, for whatever reason you decide, belong together. There are two types of BOM POMs. The names are not official. I call them lib and stack. And if you use Quarkus or Spring or Jackson, JUnit,
you are consuming them.
You have seen this BOM POM. So it's typically to find a BOM POM that defines projects that belong to the same umbrella. Say, for example, JUnit. There's a JUnit BOM that brings every single project from JUnit that you might consume. This is a library POM.
and it's already defining some versions. So while you only introduce this, you're actually introducing more information about the whole library or catalog of different libraries that's introduced in that particular package.
And the other BOM is a stack. This is the one that brings dependencies that come from different projects, but they are somehow related. So, for example, if you look at a Spring BOM or a Spring dependencies, these will import all the Spring dependencies from the other BOM, but also JUnit and Jackson and Mustache and Hibernate and JDBC, whatever it is, a lot of drivers. So, of course, all these different projects are unrelated to one another, but as an author of a Spring application, you would like to use all those different dependencies and versions that the Spring team has verified to work together. So
work together.
Yeah, so there's a BOM lib, which is the case of JUnit and Jackson on the other ones, and the BOM stack. Now, in this case, we have a BOM, which is very simple because it only defines a single dependency.
So dependency management. So in the BOM file, we only define in the dependency management block WABA 28. In the consumer, in the dependency management, we are actually importing the POM file. As you can see, there is something different called the type. So that's where we are saying, and the scope, that's why we're saying this is a POM, a BOM file. And in the dependency part, in the dependency phase, what we have is two transient dependencies. And and so what is going to happen here? What is going to happen we're going to have is we will bring the dependency management declaration, and the version is going to be 28.
This is the reason why we have BOM in the first case, because instead of writing in our consumers that I would like to use version X or Y, I will trust that someone else has defined that collection or that set of dependencies.
They already know what works correctly, what will play nicely together.
And we only import those suggestions and we use them in our consumers.
We don't need to test them or figure it out. There was a binary incompatibility or a breakage. They know what they're doing. So that's why people that are working with libraries or platforms or frameworks will actually create and publish this for us to consume.
So this increases the reusability of dependency configurations.
Now, in this next case, we have a dependency management block in the BOM file and a direct dependency on version 28. So dependency management on the BOM 26, direct dependency 28, and we have a transient dependency. So BOM files can declare whatever they want. The only thing that matters is the dependency management section.
Right.
It doesn't matter that they are defining the direct dependency, and in this case, version 28. That doesn't exist. It doesn't.
When the consumer, in this case, the base project, the one on the right, imports a BOM, the only thing that it looks at when doing set import is the dependency management block. Everything else that the BOM defines is hidden, is irrelevant. So the fact that it finds a direct dependency for whatever reason doesn't have any bearing in the resolution of the consumer
POM.
That's why version 26 is the chosen one.
Okay. So now we have in the BOM, the version 28, we have in the dependency management another entry to version 26 and a transient dependency. So we have 28, 26. What is going to happen here? So 26 is winning. Why? Because it was the second one? No, it was because why?
So the reason why 26 wins is when you look at the importing, it says, okay, first let's look in the order. I import the BOM that says it's going to be version 28. And then I have another version, which is Guava 26. Now, if I were to do things in the other case, say I define explicitly Guava version 26 and then do the importing, will I ever get version 28? No. The reason is that 26 is seen as an explicit version, and explicit versions will always win over implicit or not or undefined. In this case,
the import is implicit.
So version 26 is the one that wins, no matter in which order you put it in the dependency management block.
Okay, so now we know. And final question. So dependency management, 26 on the BOM, and on the consumer, we have in the dependencies 28 directed and transient. So what is going to happen? And we have seen this example.
If you follow the rules, just go through, I need to import a BOM, which brings the dependency management block. That is as if that dependency management block was defined explicitly in the consumer. And then we have two transitive dependencies. We've seen this use case before. I think this was question 5 or question 6. No matter where in the transitive dependencies Guava will be found, then the
direct dependency wins.
Yes.
Direct dependency wins. So 28 is the one that is going to be selected. And all these questions are in a GitHub repository. That's where you can get the GitHub, and there has several branches for the questions, for the answers, and the instruction how to run the project or to build it with Maven dependency tree. And that was it. Thank you very much. I hope you enjoyed the session. So don't forget, use semantic versioning, the enforcer plugin, that there are different rules. And if you want to know a little bit more about this, you can follow Ray Sang. He has a really nice talk about surviving dependency hell with Maven. And if you want to know more about not only dependency management resolution, but the dependency repository management, please ping me, because I'm the one working for JPro. So thank you very much.
If anything, out of all the things that we have discussed today, if there's only one single thing that you take out of this session, it's not that, well, the dependency management resolutions in Maven are wonky in some cases. No, that's not it. Please configure the Enforcer Maven plugin in your build. It's going to break it.
Yes.
And that's exactly what is expected.
Yes.
Because I guarantee you that there are issues in your builds that you are not
aware of.
And we want these builds to break as soon as possible so that we can fix these issues.
Okay, and that's it, Kurt, and we're very, very happy to have been here.
Thank you very much for this very, very interesting session. And I really like the format, because the Java puzzler approach is quite well known, but to apply it to Maven is really cool and fun.
Yeah, this is one of my favorite sessions because it's really, really interactive.
And also it makes one think that Maven is a little bit like a programming language then, if one applies a puzzler approach to the format. If it's that complicated, it's a bit like a programming language itself. Or if it's that subtle or powerful.
It's very powerful. And how has it been evolving? It has allowed for different ways or rules or to actually work. And those are sometimes not very intuitive. As I said, the order which is defined in the file matters for one case, but not the other. It is what it is, but it's important that we know it. And at the end of the day, the solution is the Maven Enforcer plugin with the rules or with the extra rules. So the solutions are already there.
So pay attention to this rule. So you're free to watch this session as much times as you want and reach us out in social media. We're very happy to engage with you. Some of these rules will be updated for Maven 4. So keep watch on that, because what we may configure today with Maven 3 might be obsolete or no longer needed with Maven 4.
Yeah. So we are actually going to update our session with more examples. And if you have questions that you would like to see then more in depth, please let us know. We are
Thank you very
happy.
much. As you can see, there are many very positive, happy people who have watched this, and it's been very educational. Thank you so very much for participating in the conference.
Thank you.
Thank you, everyone, for joining today, and keep enjoying the J Champions Conf.
Okay, we're going to end the broadcast now. Thanks, everybody.